Okay, welcome back to the second round of instructional video where we're going to look at how to convert between the mole and the particle using Avogadro's number. Now, the particle, ladies and gents, this could be anything. It could be an atom, it could be a molecule, it could even be an electron. It's pretty much any type of small individual unit. And they're all linked together by the fact that 1 mole is equal to 6.022 times 10 to the 23rd. So if you have 1 mole of atoms, you have 6.022 times 10 to the 23rd atoms. If you have 1 mole of molecules, you have 6.022 times 10 to the 23rd molecules, so forth and so on. Okay, so just wanted to kind of iterate that right there for you, and let's go into some of the conversions that you can see on exams and so forth. Here's a classic example. A 3 mole sample of water has how many molecules in it? We're going to approach solving this the same way we did with the other two problems. We need to first determine what is the question asking us to find, what did the question give us to begin with. We need to make a mole map or a map or plan of how we're going to do the conversion, and then we need to carry out the conversion with the appropriate conversion factor. Looking at this question here, I see the how many portion and I see, oh, well, it's looking for molecules, okay? Sometimes questions don't have the how many portion. You need to get a little creative with how you're going to determine what they're looking for, what they're not looking for. Typically, the thing that you're looking for doesn't have a number associated with it. It's just a unit, like this is right here. The thing that you're given is a 3 mole sample of water. This is our given. We need to start with a 3 mole sample of water, and we need to convert that over to the number of molecules. The question wants to know how many molecules will there be in 3 moles of this stuff. Okay, so we're going to start off with our map. Here we have 3 moles of water, which is H2O. I'm sure you guys knew that. And we're going to convert that over to the number of molecules of H2O. That's what we need to figure out. And actually, I'm going to go ahead and erase this and put it over a little bit further so that we can have some more room. 3 moles of H2O. I need to convert that to the molecules of H2O. Right. So let's start with set up our fraction, moles of H2O. We'll be doing a conversion, so you know you need a fraction in there. Make this a little bit longer because molecules is a long word. And then now we need to figure out what's our conversion factor. What's going to go on the top and bottom of this fraction here? Well, ladies and gents, we're converting moles to the number of molecules, okay? And if you take a look up here, whenever you're converting between particles, which can be a molecule, and its mole amount, you have to take into account Avogadro's number, which is that very famous 6.022 times 10 to the 23rd. Just like a dozen is 12 things, 1 mole is 6.022 times 10 to the 23rd. So the conversion factor here is for every 1 mole of anything. In this case, it's molecules. That's going to be equal to 6.022 times 10 to the 23rd molecules. It's a lot of molecules. And then again, these are atoms and things like that, so you will expect a large amount of them. Alright, let's go ahead and set up our conversion. We have moles of H2O right up here, so in order to cross cancel that, what's got to go down there? It's got to be the moles of H2O. They have to be the same. I'm going to keep reiterating that. They always have to be the same going diagonal. And then up top is what we were looking for. That was the molecules of H2O. And then we go to our conversion factor here. It says for every 1 mole, oops. It says for every 1 mole, there are 6.022 times 10 to the 23rd molecules. And I apologize for having to slant it up like that, but I ran out of room, okay? Guess what's going to happen to the moles of H2O, these two things right here? They are going to cross cancel. and then we're just left with the moles or the molecules of H2O, which is what the question wanted. Now here's where things get a little bit tricky. We have not been taught how to enter scientific notation into the calculators yet. So I'm going to switch over here to my hovercam screen, and I want you guys to take a look at the 3 different calculators that I have up here. You are going to want to go out and buy a scientific calculator. You have some choices. You can choose to buy the $14 to $15 ones, which are these 2 right here. The dollar store, like Dollar General, also offers them, and I think just the plain old dollar store as well, offers $1 scientific calculators, which you can purchase as well. Those are the ones that I've used in my class with you guys this past year. Since many of us probably don't have a scientific calculator on hand, I'm going to show you how to do it the classic iPhone method way. And then I will make a video in the future on how to actually use the real scientific calculators, but you're going to want to go out and invest in one. To get the scientific calculator on your iPhone, you're going to have to turn your iPhone to the side, and it's going to bring up this page right here, or this little screen right here. Let me turn off the slide, it'll probably focus better. There we go, that's a little bit better. Nope, what's it doing? There it goes, okay. So here's what we're going to do, ladies and gents. Looking back at our screen here, on our iPad screen, we need to do the multiplication of 3 times 6.022 times 10 to the 23rd power, okay? But how do you enter that into a calculator like this one here? Well, let's do this. We're going to start with 3. Give it some time to focus. We'll do 3, and then we're going to hit the multiplication sign. Now to enter the 6.022 times 10 to the 23rd, you're going to start with the 6.022. Now, many of you are thinking hit the multiplication sign. Don't do that, okay? The 6.022 times 10 to the 23rd is a whole number. It's one singular number. To get the times 10, you're going to actually hit this double E button right here, okay? And then you're going to plug in the power 23. And then hit equals, okay? And this is the answer to the question. It's 1.8066 e to the 24. We cannot write it this way. We have to replace the e and the 24 times 10 to the 24. So when we come back over here to our actual work here, we're going to write 1.806. The E is times 10 and then to the 24th power molecules of H2O. Okay. And then that's how you solve that problem now. Let's go ahead and do another one. In this case, we're going to go the opposite way. We're starting this time with, well, let me read the question to you and see if you can determine what we're starting with and what we're ending with. Suppose you have a container filled with 1.204 times 10 to the 24th atoms of hydrogen. How many moles are present? So looking at that question there, what is it asking us to find? What are we looking for? We're looking for the moles, okay? We want to know how many moles are present of this stuff, okay? In this case, it's hydrogen. What did it give us to start off with? The 1.204 times 10 to the 24th atoms, okay? So based on this, we're starting with atoms of hydrogen. In this case, hydrogen is H2. I forgot to write that in there, but hydrogen is H2. And we have 1.204. Let me rewrite this. So we're starting off with 1.204 times 10 to the 24th atoms of H2. Where are we going to the moles of H2? And now we're ready to set up our fraction, okay, our conversion. So we'll start with the 1.204 times 10 to the 24th atoms of H2. We'll multiply that by the fraction, the conversion factor, and we need to figure out, well, what is that? What is the conversion factor? Well, we need Avogadro's number, ladies and gents, because we're going from mole to particle, okay? Or in this case, particle to mole. We know that 1 mole of H2 is equal to 6.022 times 10 to the 23rd moles of H2, okay? Because 1 mole of anything, it doesn't matter what it is 6.022 times 10 to the 23rd power. I'm sorry, did I just say moles there? That is completely wrong. Not moles. It should be atoms. My apologies there. 1 mole of anything is 6.022 times 10 to the 23rd. In this case, we're looking at atoms because it says we had atoms right there. So I apologize for that. Alright, let's go ahead and set this conversion factor into the equation here. We have atoms of H2 here, which means what's going on down there? In order to cross-cancel the atoms of H2, and then that's going to take us to the moles of H2, which is the final part of our map there, so that's going to go up top. Okay, where do those numbers come from? Well, it comes from the conversion factor. It says 1 mole of H2 is equal to 6.022 times 10 to the 23rd atoms. So 6.022 times 10 to the 23rd atoms of H2. And the reason why is because atoms of H2 has that number right there in front of it. Same thing with the mole. The mole of H2 has a 1 in front of it in our conversion, so we'll put a 1 there. Alright, now it's time to go through and calculate this, and I will go ahead and switch back over to this screen here so I can show you how to do this and type it into your calculator. And I apologize, it's going to go in and out of focus because I don't have a very good camera right now. But what we need to do is 1.204 times 1, or 1.204 times 10 to the 24th. So let's plug that into our calculator here. 1.204, the double E sign, hit the double E to get the times 10 and then type in the power 24. Okay, hit equals, and that's going to give us that number there. Based on what we had here, we multiply that by 1, which would just give you that number back, but then we need to divide it by the stuff on the bottom here. We need to divide it by 6.022 times 10 to the 23rd. So we're going to hit the division sign and do 6.022 e to the 23. We'll hit equals, and then we have 1.99, which in that case we'll just round to 2. So we'll come down here and we'll put 2.000 because we have 3 sig figs here. I hope you guys watched the video on sig figs. You did, right? As the summer assignment. Moles of H2. Okay. Sig figs just tell you how to round. And then that's your final answer. And then of course don't forget to show your cross cancel though. Alrighty, I'm going to go ahead and leave it to you. You can revisit this video anytime. Try the 2 examples on the preceding page and then I will post the solution right after.